Today we're going to continue on what you've learned about scientific notation. First, I'd like to point out how useful understanding scientific notation is. For example, sometimes when you type something in a calculator that gets a super long answer, too long to fit on your calculator screen, it's going to put the answer in scientific notation to make it fit. For example, here, 20 to the power of 10 really does not get 1.024. It gets 1.024 times 10 to the power of 13. In other words, it's saying the answer is this, but with the decimal moved 13 times and a lot more zeros tagged on. So the number itself is probably about all the way to here. It doesn't fit on the screen itself, so they wrote it in scientific notation. The main thing we're going to focus on today is really what defining scientific notation and also taking a normal number and rewriting it into scientific notation. First off, it's important to know that scientific notation is written as a number with exactly one digit in front of the decimal point, and it could have none or many digits after the decimal point. And then it has times 10 to some power. And it's important that the one number in front of the decimal is not 0. It could be any number besides 0. Here's your steps for rewriting a normal number into scientific notation. First, start at the decimal point, and then count jumps as you move the decimal point until there is only one non-zero number in front of it, which is the goal. It would make it look like this. Count the number of spaces or jumps you moved that decimal point, and that tells you what the power on the 10 is. If you moved the decimal to the left, shrinking the number, then the exponent is positive. If you move the number to the right, making the number grow, then the exponent is negative. Let's go through some examples. First off, it might be a good idea to hunt down where you want the decimal to end up. In this case, we want the decimal to end up after the 5 because when we move this decimal in that direction, that 5 is the first non-zero number we come across. So this is where we want the decimal to end up. Let's count how many jumps that would take. That would take 1, 2, 3, 4 jumps. So now we write our number. It's going to be 5, and now the decimal's after the 5, so there's only one number in front of the decimal, and then 0.42. And then we add the times 10 to the power of negative 4. It's a power of 4 because it took 4 jumps, and it's a negative 4 because if we look at the original problem, it was a tiny, tiny number. To go from 5.42 to a 0.000542, that shrunk the number. So that means, since the actual number was smaller than this, it needs a negative power to represent the fact that it's 5.42 but shrunk to a smaller version of itself. And that's your final answer, 5.42 times 10 to the power of negative 4. That's in scientific notation. Let's try that with question 2. First, draw a line under the number that you want the decimal place to end up at. So this time our decimal is closer to the end, and to have only one non-zero number in front of the decimal, we'd have to move the decimal to the left to make that happen. Now we can count jumps. It would take 3 jumps for the decimal to end up after the 3. So now the number would look like 3.96355. And then because it took 10 jumps to get there, it'd be 10 to the power of, 3 jumps to get there. It'd be 10 to the power of 3. See how is 3,963 is a really big number? So if we're starting with 3.96355, to make that grow into something equal to 3,963.55, it would have to be a positive power of 3 to represent that our actual number we're talking about is a bigger version of this. A quick note on number 3. Notice how initially there is no decimal point. However, you know that means that the decimal point is just after the ones place at the end of the number. So draw on the invisible decimal point, and then work from that location till you find where you want to put the decimal. Oh, I'd want to put it here because that would leave one non-zero number in front of the decimal. Count how many jumps that is. Because that's 6 million, that's a huge number, so it'd be a positive power, and that was 6 jumps, so times 10 to the power of 6. Now here's the deal. You know how zeros after a decimal place don't really mean anything? It means you have 0 tenths, 0 thousandths, 0 millionths, and it's just 0 in all the fraction places. So really, the shortest way of writing this is just -6. So if you have extra zeros after the decimal place, you want to leave them off to write the simple version of the answer. Pause here and try the next row on your own. Go ahead and check your answers. For number 4, we needed one non-zero number in front of the decimal. The decimal started here, so we kept looking till we found one non-zero number. Oh, I need it to end after that first non-zero number. So that's where the decimal should end up. You count the jumps, that ends up being 6 jumps. So it becomes 1.02 times 10 to the power of -6, because this is a tiny decimal number, and you only get that from a negative power. Here, you wanted to write in the invisible decimal. Since there wasn't one in the problem yet, it would always go after the ones place. And then from that place, you keep looking through the zeros until you find the first non-zero number. Oh, I need it to end right there. The decimal needs to go after the 8, so there's only one number in front of the decimal. So now it's 8.000 times 10 to the power of 3, but 0.00 doesn't mean anything, so you just leave it as 8. So here, we needed to move the decimal until it ended up after a single non-zero number. Okay, there it is. That takes 3 jumps. So it'd be -6.003 times 10 to the power of -3, because anytime you have a decimal number, that must have come from a negative power on the 10. Pause here and try the next 6 problems on your own. Go ahead and check your answers. Don't forget, if there's no decimal in the problem yet, you want to write in the invisible decimal after the ones place. If you have a huge, gigantic number, that means it must have resulted from a positive power on the 10. But if you have a really tiny, less than 1 number, that must have resulted from a negative power on the 10. Now for the challenge problem. Sometimes they're going to ask you to multiply 2 numbers in scientific notation. So here's one scientific notation number, 3.1 times 10 to the power of 7, times a second scientific notation number, 2.0 times 10 to the power of 9. When you see a problem like that, keep in mind the commutative property, which says when I have a chain that's all multiplication, I'm allowed to shuffle the order of my numbers around. And you could use that rule to shuffle the numbers so that the coefficients without powers are next to each other, and then the tens with powers are next to each other. Oh, this 10.0, this 2.0, that's really a fancy way of just saying 2. So it's really 3.1 times 2 times 10 to the power of 7 times 10 to the power of 9. Now, the normal coefficient numbers without powers, you would just multiply them normally. 3.1 times 2 would get you 6.2. And then with the tens, because they have the same base, they're both base 10, and you're multiplying them, you add your powers. 10 to the power of 16 from 7 plus 9. And that's your answer. You can just leave it in scientific notation. Pause here and try number 14 on your own. So first off, you shuffled your numbers so that the coefficients were in front and then the tens with the powers were together at the end of the problem. Then you multiplied the 4 times 3. 4 times 3 got you 12. And then I want to point out that when you add these powers, 13 plus negative 5, it really works out because it's a negative number to being 13 minus 5. So it'd be 10 to the power of 8. Now, there's one problem with this answer. The answer is not in scientific notation. Oh no, because if you look at it, 12, the decimal, is after the ones place. Invisible decimal after the ones place here, meaning there's two numbers, two digits in front of the decimal, and we want only one number in front of the decimal. So we're going to have to rewrite it into scientific notation. So we'll have to do one jump to move the decimal, so there's only one digit left in front of the decimal place. And since that makes it to 1.2, we're going to have to add 1 to the power to balance out moving the decimal once in the direction that shrunk it. So if you move the decimal in a direction that shrinks your number, you're going to have to balance it out by adding 1 to the power that would grow your number. So your final answer is actually 1.2 times 10 to the power of 9. You'll only have to do the step where you when you notice that your answer isn't in scientific notation yet, notice how it wasn't necessary for number 13 when the answer was already in scientific notation with only one number in front of the decimal. Great job today, guys. Don't forget to turn in a picture of your notes on Schoology.